Welcome to the lesson about sides and angles in triangles. In this lesson, we will look at the particular relationships that sides and angles have within individual triangles. Now, within every individual triangle, there is a special relationship that the longest side is opposite the largest angle, and the smallest side is opposite the smallest angle. We can illustrate this by drawing some isosceles triangles within circles. So if I draw a circle and draw a triangle within that circle, I automatically know that two sides of that triangle are radii, so they both congruent, with my two base angles as being congruent. Now, after labeling the angles within this circle, I want to go ahead and say that angle A is going to be greater than angle B and angle C, since angle A and B are the same thing. Now that would mean that BC, angles A opposite, is going to be bigger than AC and AB. Now, while this might seem difficult to interpret at the moment, let's take a look at another example where the angle is perhaps a little bit smaller. So I have another circle and another two sides, and this time around the third side appears to be smaller, but the two sides are still indeed congruent, and the two base angles are congruent. Now, in this particular case, I'm going to go ahead and say that segment BC, that small side, is going to be smaller than AC and AB. Now, because of that, I will know that its opposite angle, angle A, will be smaller than the two congruent angles, angle B and angle C. Essentially, the smaller an angle, the smaller the side it's going to be opposite from. Now, let's apply this to solve some of these problems. In the first one, I'm trying to find what's the smallest angle within the triangle. Now, I know how long each side is, so let's look for the shortest side. I can see that side BC is the shortest at 1.32, so angle A, its opposite, has to be the smallest. In this second problem, I can do very much the same thing. I notice that AB is the smallest at 2 inches, so the angle opposite AB, angle C, will also be the smallest. In this third example, I don't have any side measures, but I know that if I have any number x, x minus 1/2 will be the smallest, x plus 1 will be larger, so the smallest side, CB, will have the smallest angle. Now let's flip the script and name some sides. So by looking at this particular problem, where the angles are x, x plus 7, and x minus 1, I know that without knowing those values, I can simply add them together if I wanted to, and set them equal to 180 degrees. So after working algebraically, I get 3x plus 6 equals 180. Subtract 6 from both sides, I get 3x equals 174. And then my x equals 58. So angle A will be 58, angle B will be 57, and angle C will end up being 65, 58 plus 7. Since angle B is the smallest, then side AC is the shortest side of this triangle. Now let's take a look at a more complex example where I might have to combine various properties of triangles. So I have numerous different triangles here, and I want to find the shortest side of each one. So the first thing I'll do is solve for x. So I know that I can add 30, 40, and those two x's together to equal 180. And after doing some algebra, I get that 2x is equal to 110, and that x is ultimately equal to 55. So let's fill in what I know. I know that this angle HBE is 55, HBA is 55, and GAH is also 55. So I want to start off by trying to find the shortest side of ABE. So what's the smallest angle in ABE? It's going to be angle A. So BE is the shortest side. So now I go to ABG, this very large angle here. Well, I know what my angles are here, 85 and 55. So angle G must be 40. And since G is the smallest, its opposite side, AB, must end up being the shortest. So the shortest side of ABG ends up being AB. To finalize, let's take a look at AHG. So AHG, I know that this angle GHA is going to be 80, so G is the smallest angle again. So its opposite of this one, AH, is the shortest side. For the fourth example, I'm looking for BEH. I can find angle EHB as 85, so angle E is the smallest angle, and its opposite, side BH, ends up being the smallest side. Lastly, I'm looking for the shortest side of AB. H. I almost have all the angles. I know that angle AHB should be 95, meaning that angle A is the smallest and its opposite BH is the smallest side of that particular triangle.